The screen is visible. My screen is visible.
Yes, sir.
Yes, okay, fine. Just wait. Can wait for 1 or 2 minutes, others to join. Hello? Connecting with you. Okay, fine. So in the class, we are going to discuss quadratic form to canonical form. In the last class, I have taken this quadratic form to canonical form, but many of them were absent to the class. First, I will see that what is meant by that quadratic form. Actually, the second degree equation in any number of variables. The second degree equation in any number of variables is called the quadratic form, and it is denoted by Q. Denoted by capital Q, and it can be written as X transpose AX, where X is the non-zero column vector, A is the square matrix. Okay, now one quadratic form X transpose AX is given. How to convert into that matrix? In case the matrix is given, how to convert into that quadratic form? We will see through example. Simple problem. Write down the matrix of the quadratic form. Two x1 square minus 2 x2 square plus 4 x3 square plus 2x1 x2 minus 6 x1 x3 plus 6 x2 x3. It is a given quadratic form. For this quadratic form, we have to write the matrix A. How to convert? Here what? Our aim is to find the square matrix A for the quadratic form. For the quadratic form Q. Okay. Now I will explain step by step how to write the matrix for the given quadratic form. So here, how many variables are there? The quadratic form contains 3 variables. What are the variables? x1, x2, x3. Okay. So in case only 2 variable x1, x2 is there, you will get the 2 by 2 matrix. In case 3 variables are there, you will get the 3 by 3 matrix. Okay. So you will get that the matrix in the format of A11, A12, A13, A21, A22, A23, A31, A32, A33. Those who are attending the last class can understand very easily this concept, but those who are attending new means then you have to be concentrate here how to find this. Now listen, the coefficient of A11 carefully write. The coefficient of A11 is that the coefficient of x1 square in the quadratic. What is A11? This position is that A11, that will be the coefficient of x1 square in quadratic form. Similarly, A22, where is A22? Here it is A22 there. This A22 is that the coefficient of, you can write in note also, coefficient of x2 square in quadratic form. A33. Where is A33 here? The diagonal element A33. The diagonal element A33 is there. It is the coefficient of x3 square in quadratic form. Okay. Now listen. You can form the matrix here, 3 by 3 matrix. Now you have to identify where is x1 square, where is x2 square, where is x3 square. Here it is x1 square is here, x2 square is here, x3 square is here. Their coefficient should be in the place of their, what is mean by coefficient? X1 square coefficient is 2, x2 square coefficient is 2 minus 2, x3 square coefficient is 4. Okay. So what is coefficient of x1 square in quadratic form? It is 2. A22. Coefficient of x2 square in quadratic form is minus 2. A33, the coefficient of x3 square in quadratic form is 4. That should be the diagonal elements. That means, where is that A11? A11 is here. That is 2. Please keep it in mind that what is A11? A1 is coefficient of x1 square in the quadratic form. A22 is coefficient of x2 square in the quadratic form. A33 is the coefficient of x3 square in the quadratic form. So 2, the next diagonal element is minus 2, and then next diagonal element is 4. In case any doubt is there in middle, you can ask. Okay. Now, come to that next one. The next one is that position A12 and A21. The positions A12 and A21. So here it is A12 and A21. This position is there na? A12, A21. I will write here A12 equal to A21. Both are, that should be equal value. That is equal to A11, A2 equal to 1 by 2 coefficient of x1, x2 in quadratic form. A12 and A21 position. A12 and A21 position. A12 and A21 position should be that 1 by 2 coefficient of x1, x2 in the quadratic form. So what is your next work? You have to identify where is x1, x2 is there. So this x1, x2 is there. Their coefficient is what? 2. Okay, the coefficient is 2 here. That means, so what is A12 and A21? A12 and A21 value is 1 by 2. What is the coefficient there? 2 is the coefficient. Therefore, that value is 1. Okay, so here you have to write 1 and 1 here. A12 and A21 position should be that 1 by 2 coefficient of x1, x2 in the quadratic form. This value is 1. Similarly, A13 and A31 position. What is A13 and A31? Here. A13 and A31 position. This A13 and A31 position is 1 by 2 coefficient of x1, x3 in the quadratic form. Next, you have to identify where is x1, x3 in the quadratic form. See, in the quadratic form, where is x1, x3? Here it is x1, x3. So, what is the coefficient? Minus 6 is the coefficient. Minus 6 is the coefficient. Therefore, A13 equal to A31 equal to 1 by 2 of minus 6. That means minus 3. So, you can write that minus 3 in that A13 and A13 position. So, what is A13? Here it is A13. Here you can write minus 3 and then A31. It is minus 3. Only remaining is there this position and this position is there. That means A23 and A32 position. This A23 and A32 position, can you guess this? A23 and A32 position will take that 1 by 2 coefficient of x2, x3 in quadratic form. So here x2 x3 is here. What is the coefficient? 6 is the coefficient. So 6 is the coefficient means we can write that a23 equal to a32 equal to 1 by 2. The coefficient of 1 by 2 coefficient of what is the value? 6. So that is equal to 3. So this value will be that 3 and so here, sorry, I'm writing in 3 here. Okay. So for any quadratic form, you have to write the matrix. This matrix should be the symmetric matrix. When you are converting from matrix, you are converting from that matrix, sorry, you are converting from the quadratic form to matrix, is there? The matrix should be the symmetric matrix. So what are the things you have to be identifying? Where is x1 square, x2 square, x3 square? This x1 square, x2 square, x3 square coefficient should be in the diagonal. And then next you have to identify x1, x2. This x1, x2 coefficient is take 1 by 2 of this. Take 1 by 2 of this. Just wait. No. Next one is x1, x2. For that x1, x2, you take that 1 by 2. Don't write the directly the 2 and 2 here. That will be wrong. So if you are writing that coefficient is directly, then it will be that wrong. If it is, listen, x1 square, x2 square, x3 square should be in the diagonal. Clear na? Then the coefficient of x1, x2, that 1 by 2, that value is taking 1 by 2, and then you have to write in the position of a12 and a21 position, and then x1, x3. This x1, x3 should be in the position of a13 and a31 position, and then x2, x3 is there, na? That x2, x3 should be in the position of a23 and a32 position. Okay, it is very simple example. Now listen. Vice versa. In case one matrix is given, how to find that quadratic form? For example, I am writing this. Write down the quadratic form. Write out the quadratic form corresponding to the matrix. A. The matrix will be given. You have to write the quadratic form. 2, 4, 5, and then 4, 5 also here. 4, 5, and then 3, 1, 4, 3, 1, 1, 1 here. In case if it is that quadratic form, then you can write the solution for this. Now listen. Here also the given matrix is the 3 by 3 matrix. Matrix is 3 by 3 matrix. So you will be having that quadratic form in 3 variables. You will be getting the quadratic form 3 variables, say x1, x2, x3 are the 3 variables. Now see what are the diagonal values are there. The diagonal values are 2, 3, 1. Therefore, we can write that 2, x1 square plus 3 x2 square plus 1 into x3 square. So the diagonal value should be that square and then plus. Here a1 a2 is there na? Sorry, a12 a21 position. Take any one of them. A12 and A21 position is 4 is there. Okay, fine. So for this you have to double the value. You have to find the double the value. Double means 8. 8 x1 x2. In case if you are quadratic form to matrix mean you have to take 1 by 2. When you are converting from that matrix to quadratic form means a double. Okay, that is the reverse one. So double the value of A12 and A21 position and then write here 8x1 x2. Similarly, for A13 and A31 position, A13 and A31 position is 5, then it can be written as the coefficient of x1 x3 and double. That means double is 10. Okay, you have to write very carefully when you are writing that matrix to quadratic form and then quadratic form to matrix. Only one remaining value is there. Already everything is completed. Only one value is there. That means A13, sorry, A23 and A32 position. A23 and A32 position. That means double. Double means 2. The coefficient of x2, x3. Okay. Is it clear? It is very simple. When you are converting from that matrix to that quadratic form, the diagonal elements 2, 3, 1 is there. Then you have to write the coefficient of x1 square, x2 square, x3 square. And then the A12 and A21 position should be the double of x1, x2 coefficient. And then A13 and A31 position, A13, A31 position should be the double of x1, x3 coefficient. And then this A23 and A32 position is the double of that x2, x3. Okay, fine. What is the use of this quadratic form? That quadratic form into canonical form you have to be convert. You have to convert from quadratic form to canonical form. Quadratic form is x transpose AX. So what is meant by quadratic form to canonical form? Quadratic form to canonical form is that quadratic form in that format of x transpose AX, which is equal to canonical form y transpose dy. Actually the D is there na? The D is the diagonal matrix. D is the diagonal matrix. So where you get that idea to get the diagonal matrix is that see the chapter. Once again I will repeat that anyway. You can see the chapter. Diagonalization of the matrix. Diagonalization of the matrix by orthogonal transformation. By orthogonal transformation. Okay. Anyway, actually I have taught in the class of this diagonalization of the matrix by orthogonal transformation. Only one step we are extending to find that quadratic form to canonical form. I will explain in the problem how to find that quadratic form to canonical form. It is a very lengthy process. We know that already I have written that the format of, sorry, the procedure for diagonalization of the matrix by orthogonal transformation. Now we will see how to find that the quadratic form to canonical form through one problem. It is compulsory problem actually. It is a compulsory problem. It will come. Okay, now we can write one problem here. Already now this time is 3:39. Only 20 minutes is there. Very quickly we can complete it now. Okay, fine. So within 20 minutes I will try to complete this problem because it is very lengthy. Please cope up with me. No need to write this. I will write. Then afterwards you can write after. Okay, first I can write the question here. Reduce the quadratic form. Reduce the quadratic form. X1 square plus 5x2 square plus x3 square plus 2x1 x2 plus 2x2 x3 plus 6x3 x1 to the canonical form. Okay, now see that write the solution here. The first step is from the quadratic form you have to write that matrix. So what is the matrix of the quadratic form? As I told, the matrix of the quadratic form, A equal to what? The matrix is 3 by 3 matrix. You will get that, sorry, because the given quadratic form is that the in 3 variable, therefore you will get the 3 by 3 matrix. What are the diagonal elements? What are the diagonal elements? Quickly, can you tell me that, anyone? Can you tell me the matrix
So
also?
151.
151 is the diagonal values. Then A12 and A21 is A12
1.
and A21. 1 1. Very good. And then A23 and A13 and A31 position. This position. A13 and A31 position.
3.
3. Exactly. Good. And then only one remaining is there. We can do fast.
1.
1. Good. So we can form the matrix. We can write the characteristic equation. The characteristic equation is lambda cube minus A1 lambda square plus A2 lambda minus A3 equal to 0, where A1 is sum of diagonal elements, A2 is minus of, already you know this, 5, 1, 1, 1 plus 1, 3, 3, 1 plus last one is 1, 1, 1, 5. So this value is what? 0. 5 minus 1, 4. And then 1 minus 8. Once again 5 minus 1, 4. So you will get that is equal to 0. And then A3. A3 is determinant of A. So that is 1 into 4 minus minus of minus 2 plus 2, I think, because minus 1 into 1 minus 2, yeah, minus 1 plus 2, then plus 3 into minus 14. So that value is 30 minus 36. So here the characteristic equation is, if you are able to solve with me, solve it, otherwise you can solve it afterwards. Just listen. Lambda cube minus 7 lambda square plus 36 equal to 0. Okay, so here 1 and minus 1 is not possible for this. So 1 minus 7, 0, 36. We can go for 2, 0, 1, 2, 6 minus 5, and then minus 5 means here 2 into minus 10, so it is not possible. I think we can go for that minus 2 here. Minus 2, minus 2, minus 9, 18, then 18 here, minus 36, 0. So lambda equal to minus 2 equal to, and then if you are solving this, you will get that 3, 6 are the roots. I think it is the first problem when I solving that eigenvalue eigenvector problem. Maybe you can check it that minus 2, 3, 6, minus 2, 3, 6 is that eigenvalue eigenvector problem. Maybe first problem. I have solved the same problem in the class. You need to be checked, please, to find the eigenvectors when lambda equal to minus 2. When lambda equal to minus 2, then a minus lambda I. What is a minus lambda I equal to 0 into x? No? A minus lambda into x equal to 0. That is, the matrix is that 1 minus lambda 1 3, and then 1 5 minus lambda 1 3 1 1 minus lambda. Okay, so and then you have to multiply with the x1 x2 x3 equal to 0 0 0. So when lambda equal to minus 2 means you will get the 3 3 1 3, and then 1 7 1, and then 3 1 3. So if you are solving this, you will get that. I think you are not having any doubt in finding that eigenvalue eigenvector maybe. Okay, take any two non-identical rows. Then we can write that x1, x2, x3, x1, x2. Then 3 1 3, 3 1, and then here 1 7 1, 1 7. So what is x1 here? X1 is leave that row, 1 minus 21. X2 is leave it that 0. X3 is leave it this. So that means x1 is what? Minus 1, 1 minus 1, or otherwise 1 0 minus 1, vice versa. Anything you can take. Second one, case 2 is, similarly we can find that if lambda equal to 3. If lambda equal to 3, then minus 2, 1, 3, 1 2 1, and then 3 1 minus 2. x1 x2 x3. So if you are solving the same way, you will get that x2 equal to 1 minus 1 1. Okay, you come to case 3. Here I am not writing fully that finding that eigenvalue eigenvector, because already we have solved many problems based on this eigenvalue eigenvector. That's why I am going directly lambda equal to 6. So when lambda equal to 6, you will get that matrix minus 5 1 3 and then 1 minus 1, 1, 3, 1 minus 5. See, only thing is you should know how to convert that quadratic form into matrix. Please you revise this video 2 or 3 times for the better understand. Okay. So here when you are solving in the same way, you will get that x3 equal to 1 to 1. Very important step here is finding the eigenvalue eigenvector is okay. That very important step is the verification of orthogonal in pairs. It is very important step. In case that orthogonal in pairs is not there, you will not get that the diagonalization of the matrix. Okay, verification of orthogonal in pairs. So what is the orthogonal verification? Is that x1 transpose x2 equal to x2 transpose x3 equal to x3 transpose x1 equal to 0. So you have to verify this. So what is x1 here? 1 0 minus 1. x1 is 1 0 minus 1. x2 is 1 minus 1 1. 1 minus 1 1. So you will get that 1 plus 0 minus 1, it is 0. And then x2 transpose x1. x2 transpose is 1 minus 1 1 and then 1 2 1. So you will get that 1 minus 2 plus 1. It is also equal to 0. Similarly, you can prove that 1 to 1 x1 is 1 0 minus 1. That is also 1 plus 0 minus 1 equal to 0. So now it is satisfied. The orthogonal in pairs. Now we can go for that, form the model matrix M. So what is the model matrix M? Model matrix M is that whose columns is, how to find that model matrix? Anyone? Whose columns are
Eigenvectors are the columns.
eigenvectors. So 1 minus 1, 1 0 na, 1 0 minus 1, and then 1 minus 1 1, and then 1 2 1. Fine. So after finding this, the same problem have we done in the class? Maybe. Am I repeating that same problem? You can find that n. N is the normalized model matrix. No one is answering my question. Normalized model matrix. The last class, have I done the same problem inside the class?
No, sir.
Yes, na?
No, sir.
No?
Yes, sir. No.
Okay. Minus 1 by root 2. Okay. So here 1 by root 3 minus 1 by root 3, 1 by root 3, 1 by root 6, 2 by root 6, 1 by root 6. Okay. So next we have to find that n transpose an. Next we can find n transpose n. That is n transpose n is 1 by root 2, 1 by root 3, 1 by root 6, 0, minus 1 by root 3, 2 by root 6, then minus 1 by root 2, 1 by root 3, 1 by root 6. A is that matrix 113 and then 151, 151 here, 1. And then n is 1 by root 2, 0, 1 by root 2, 1 by root 3, minus 1 by root 3. I am writing here directly, but you have to be solved one by one. Okay, 1 by root 6. First you have to solve that n transpose A, then n transpose an, 2 by root 6. And then when you are solving this, it is not compulsory. You have to solve that n transpose A. You can find that an, then also you can find n transpose an. Otherwise, first you can find n transpose A, then you can find that n transpose an. Okay, so here if you are solving this, you will get that minus 2, 0, 0, and then 0, 3, 6, 0, 0, sorry, here 0, 0, 0, 6 here. That is the value of D. What is D here? D is that minus 2, 3, 6. These are the eigenvalues. Eigenvalues of A. Okay, fine. For this, you have to find the canonical form. Canonical form is Y transpose dy. That means here Y is the non-zero column matrix y1, y2, y3. And then D is the diagonal matrix. If you are multiple this, what happened is Y transpose y1, y2, y3. Then the matrix is diagonal matrix minus 2, 0, 0, 0, 3, 0, 0, 0, 6, and then Y is either y1, y2, y3. So if you are multiply this, you will then get that canonical form C equal to only square values are there, minus 2 y1 square plus 3 y2 square plus 6 y3 square. So this is the canonical form. This is the process from that quadratic form to canonical form. In the quadratic form, how many terms are there? 6 terms are there. In the canonical form, only 3 terms are there. So you are transforming one form to the another form by reducing the terms. Okay, that means you are reducing the complexity of that problem. So that is the usefulness of that quadratic form to canonical form. Okay, so in the class what we have discussed that we are converting the quadratic form to canonical form. First we have to find that quadratic form to matrix. In the through problem we have seen that, through problem we have discussed that. After, in case one matrix is given, how to write that quadratic form for this, then we can write that we can find the quadratic form to canonical form. Okay, so from the quadratic form to canonical form, what is the procedure? From the quadratic form Q, you can find the matrix A. From the matrix A, you can find that the characteristic equation. From the characteristic equation, you can find the eigenvalues. From the eigenvalues, you can find that eigenvectors. From the eigenvectors, you can find that model matrix M. From the model matrix M, you can find N. Then you can find N transpose A. Then you can find N transpose AN. Then you can find that the value of D. Then you can find the canonical form C. So this is the procedure. Don't skip any step. Okay, for the practice, I will send more problems. Okay, I am planning to take that additional class today. after some time. Those who are interested can join, otherwise you can see that video material. Okay, I will post the video material. Now you are having class 4 o'clock. Is it free? Means we can
Yes,
continue the
sir.
class.
Sir is come, sir, now.
Okay, okay, fine. Okay, you can leave the class now. No issue. You can leave the class, you can continue that class.